Hi everyone, welcome back to day 11 of Advent of Code. Today's challenge is called Plutonian Pebbles, like something radioactive. So let's see what this challenge is and I'll explain it to you. Okay, so today we are in Pluto and we have a bunch of stones lined in front of us and they have some number engraved on it. Every time we blink, something happens to these stones, and there is a certain pattern to what happens to these stones. If the stone has a number 0 engraved on it, then the number is replaced with the number 1, and if the stone has even number of digits, then it breaks into two different stones. The first half of the digits is on the first stone and the second half of the digits is on the second stone. Then if we have anything else, the number engraved on the stone gets multiplied by 2024. And suppose they've given an example here. If there is a number like 1000 which is even, so it will split into something like 10 and 0. So that it will not be 0 0, it will become 0 because it's a number, it's not a string. Okay, so they've given some examples here. So there is 0 1 10 99 999. After we blink once, 0 becomes 1, 1 becomes 2024, 10 becomes 1 and 0 since it's even, 9 becomes 9 and 9, and the fifth stone, which is 999, becomes 2024 into 999. So this is what we get as a result, and here after 6 blinks this becomes such a huge thing. But what we are interested in is the number of stones at the end of how many times we blink, and we have to calculate after 25 times, which is like this huge for this input. Interesting. Whenever the inputs are small, the question is scalar. Okay, let's try this. Okay, so this is the solution I've come up with. Since we are dividing the stones every time we blink based on some condition, or changing it with some number but eventually dividing it, we should think of each stone as an individual state, and that state changes every time we blink, and this state can repeat also after a certain amount of time. Since we have, in that example that was given to us, this 125, it will be multiplied by 2024, then it will become some number. If it is if the length of it is divisible by 2, we will divide it into 2 halves. So suppose that becomes something like, or let's not suppose, and I'll just calculate that. If the number that it comes up to is this, so this will become 253 and 0, and it's possible that we'll eventually get back 0 somewhere else or 253 somewhere else, and like even when we are dividing 17 into its constituents. So what my idea was that we will use recursion and keep do one at a time. We will divide it all for all the 25 links, then come back, start with this one, do it for all the 25 links. And so what that will help us is with knowing that in this state, for these many remaining blinks, we got a count of X, so that the next time this happens again, we will be able to easily like remember that this had happened and use that. So that is what caching is. I have not used caching here, but because I tried running the problem and running this code, and it immediately gave me an answer, but it's easy to use it as well. So since we don't need to right now, I won't be using it for this part. Probably in the next part, if we need to use it, then I will use caching, but I'll explain how I'm doing it. So we have a method. Okay, let's start with processing input. Pretty simple. We're just splitting it with the space. Since our input is in this format, even the actual input is in this format, where it's divided by each stone number is divided by a space, is separated by a space. So now and then we are mapping it to a number. Now in this count stones after blinking method, we are taking the stones which are currently given to us in the input and the number of blinks that we have to do before finding the number of stones that they have divided into. Then for each of the stone, we are checking what the condition is. This is the terminal condition for our recursion. So starting here, the new stones which are formed out of the first stone, like in this example 125, the new stones that will be formed out of it will be, if it is 0, it will become 1. If the length of it is divisible by 2, then it will become 2 parts of that. And if it is none of them, which in our 125 case would be this case, we will multiply it with 2024 and put it in this new stones. And now only for this new stones we will do the counting. So that's how that recursion goes on till the point that we get number of blinks is 0. In which case now we are not going to blink anymore. So we will just, that one more stone that has come to us, we will count that and then return that count. I have written return here because this for each expects us to return something to for each, and then we return it from the main method. Instead, if you use for loop, you don't have to do this. You can just return from here, return 1 from here itself. Yeah, so that's how it happens. That will happen for every stone, and like we're computing a lot of things, but since it's happening pretty fast, I thought I'll leave it. But I've only done that with our dummy input. Now let's see with the actual input. It was pretty fast. So let's not cache, because at least I can save up on memory in that way. Okay, so let me share that screen. Alright, we got this answer. Now let's do part 2. Okay, I don't even need to take some time to understand what the question is. Instead of giving us a more complicated question, they're just asking us that we should find out what happens after 75 times of us doing this. So now in part 2, let me share to our code. We just have to run the same thing, but with 75 as the number of blinks. I have a doubt that this will take a lot of times, or it'll give us a memory exception, because we're going so deep into the recursion, so we may face a stack overflow. But let's try it. Let's try it with the dummy first. There you go, it's taking very long. So now I'm going to implement the caching and then I'll get back to you. Okay, so not much has changed. What we've done here is we've added this caching thing, which is basically a dictionary, and then we are checking if we have a cached result for our current state, which is the stone which is being calculated, and the number of blinks. We're storing it in cached result. If there is a cached result, we will add that to the count and return it. If not, then we will go through the entire process. Whatever result we get, we will store it to the cache in that state and continue with the process, so that if it ever happens again, it'll work. So as you can see, we got the result pretty instantaneously. So now let's try it with the larger input and see if it still works. Okay, that's quite a huge number. I'm kind of worried that it's not crossed the limits of our integer here. Best of luck to me. All right, we got it. This was a very fun question. These kind of questions, wherever we can think of recursion, where there is a repeating process, I think we should immediately just make it, like, code it in the form that caching is possible. If we use the actual pattern and did it that way, I think it would be very difficult. Like if we hard coded it, like in the other problems that we have done, where we actually used the string and then divided it and kept track of it and all that, or an array, whatever, I think that would become very, very, very inefficient, and we would have to change the code entirely for part 2, even if it worked for part 1. So I think this went well. See you tomorrow. Bye bye.